understand. Now I will start the session from semiconductor electronics. If you see in NEET exam or JEE exam, what is the importance of this? One question compulsory from this topic in JEE, 2 or 3 questions for NEET exam. 2 compulsory, sometimes 3 questions also they are asking. I think so. The every competitive exam aspirant, especially in physics, you can start the session with, you can start the answering the questions with the lesson is semiconductor electronics. Why? Because without any suspension, you can answer, you can get answer only by this lesson only. After this, current electricity. But this is the importance of the lesson semiconductor electronics. Okay, right. So you can see here I have given some questions. First question I will read once. A PN photodiode is made of a material with a band gap of 2 electron volts. The maximum frequency of the radiation that can be absorbed by material is nearby. So to adjust the place, I did not write the options. I have given direct answer only. Right. So here, if you see semiconductor electronics, as per the analysis, what are the important regions are there? What are the important corners we have to study? Here we have 3 corners. The first one is basics, introduction of semiconductors. That is related to P-type semiconductor, N-type semiconductor, band gap, bandwidth related. The second corner is diode and transistor. Diode and transistor. This time we have to keep more concentration on diodes only. Why? Because a part of transition is removed from the syllabus. And third is very, very important, guarantee one question, that is from what? Logic gates. If you see recent exam, you have written CET. In that CET exam also, they have given 3 questions. First question is given circuit question. It's very easy. Circuit question is given. One diode, one capacitor given. Find out potential between the capacitor. If you see the second question, that is logic gate is yes, logic circuit is given. 2 AND gates. Output they have asked. That is also direct question. Third question, one theory type question given. What is hole? Definition of hole is given. So basics only they have asked in asking from this topic. Okay, so these are the important regions from the semiconductor electronics. If you see the first question, a photodiode made up of material with band gap is given, that is 2 electron volts. So about this band gap, so different materials, different diodes have different band gaps, as you know that. It is given in electron volts. It's nothing but electric field strength, strength of electric field, that is 2 electron volts. The maximum frequency of the radiation that can be absorbed by material is nearby. So what we have to find out is, frequency of radiation. So in generally, frequency of radiation formula, C is equals to nu lambda. As you know, velocity or speed in light is equals to C, nu into lambda. So nu is equals to C by lambda. So that here, what is C is constant. What is C value? 3 into 10 power 8. It is constant. Lambda, is it given? No. What it is given? This band gap is given. So what is band gap? Band gap is 2 electron volts. Okay, yes. What is the lambda? Lambda is equals to Hc by E. It is a standard formula we know. So that what is H into C value? As you know, this is 12,400 by electron volts by E. E value how much given? 2 electron volts. So that this is equals to, on simplification, 6200 electron volts. So this is what? Lambda meters. So this is what HC by E is equals to 12,400 by 2, that is 6,200. Now what we have to do? C by lambda. C by lambda means C value how much you have? C value is equals to 3 into 10 power 8. This is 6,200 angstroms. So this is 3 into 10 power 8 by lambda is equals to 6,200. 6,200 into 10 power minus 10 meters. Then you will get an answer 5 into 10 power 14 hertz. Yes. So this is a basic idea about this. What they have given, just this is given band gap, that is what 2 electron volts. Now I get lambda from this. So now lambda is equals to 6,200 angstroms. Now nu is equals to C by lambda. C value it is and lambda value from here. Now your answer is 5 into 10 power 14 hertz. Okay. Yes. Hope you understand. This is the basic model question from introduction topic. Right. Next you can see here I have given 2 circuits. If you see the first one is in this particular circuit 1, 2, 3. 3 resistors are there. 1 diode is there. 1 cell is there. 30 volts. VAB, potential difference between the, we have to find out, which is very, very, very important for all competitive exam, whatever it may be, JEE or NEET or whatever it may be. It's very standard question. The circuit simplification type. Almost you have an idea in current electricity. Just here what is extra? Diode only. What we have to do? Whether the diode is a forward bias or reverse bias, we have to know. Then everything comes easy. Right. So that it is 30 volts, it is the direction. So that positive to positive. Diode positive connected to positive terminal of potential difference. Potential difference positive, diode positive. So it is a forward bias. No doubt at all. So it's not a problem. Next, it is 10 kilo ohm, 10 kilo ohm, 10 kilo ohm. So potential difference VAB we have to find out. See, just like in current electricity circuit simplification, this is A, this is B, I have to find out potential difference. Then from here what is there? Another resistance is there. This is another resistance. So that it is 10 kilo ohm, 10 kilo ohm. To find here what the potential, the same potential here also there. Why? Because these two are in parallel combination. If this diode is an ideal diode means what? The resistance of diode is negligible. Then it is considered as a ideal diode. Understand? Right. So this is one simple circuit. This 10 kilo ohm, 10 kilo ohm in parallel combination. So that AB is the same potential for these two. So if I want to get potential, first I have to find out the current. So how can I find out the current? Current through this means, first if I know the total current, if I know the total current of the circuit, I can find out the branch current. Or directly I can find out branch voltage. We have the formulas for branch currents and branch voltage. So these two are in parallel. So what parallel? 10 kilo ohm and 10 kilo ohm. Parallel. So that what will happen? Resultant effective R effective is equals to 10 by 2. That is equals to 5 kilo ohm. Now these two effect is how much you get now? 5. Now just I will redraw the circuit. It is 1. It is the cell. Now here I have, it is 5 kilo ohms. It is what? It is A, it is B. Now I have here what? 5 kilo ohms. Here it is how much? 10 kilo ohms. Here it is how much? 30. Now you have options. You know how to find the current. Now these two are in series. You can find out effective resistance and it is potential difference. Now you can find out I, and then you can find out that, or directly you can find out V, branch voltage. What is the formula for branch voltage? V is equals to that is what VAB is equals to total potential by this is what is the ratio, V into R1 by R1 plus R2. What is V given? 30, right? Into what is R1, where we are going to find out 5. R1 plus R2, 10 plus 5, 15. So this is 2, that is equals to 10 volts. Okay, I will check that answer. What is the answer is, as it is a given circuit, yes, 10 volts is answer. 30 by 5 plus 10, 30 by 5 plus 10 into 5, right? So this is the formula, VAB is equals to total potential into R1 by R1 plus R2. Why? Because these two are in series. As you know, the formula for branch currents, as per that we can substitute VR1 by R1 plus R2 in current electricity. We are familiar with this, so that on simplification, what is the potential difference between here? AB is equals to 10 volts. Okay, fine. Right, go for next question. Here there will be another question is, which is related to circuits. This is also previous JEE question, JEE model question. You can see two switches are there. In the two switches, one bulb is arranged LED. One LED is there. Here one more resistor. Here one more resistor. Some values might be, whatever it may be. The concept is what we have to study. Correct Boolean operation for this. Correct Boolean operation. So we have some Boolean operations like AND gate, OR gate, NAND gate, NOR gate, like that. Here which is the correct? We have to find out. See on which base it is given. Input generally what? 1 0 0 1 1 1 0 0. These are the general inputs. So for example, from here it is connected to earth, means it is a zero potential, we know. For example, it is a higher potential, it is a lower potential. So in generally the electric current is flows from higher potential to lower potential. To glow the bulb means on. On is always represented with 1. You know that it is a standard values in electronics. In digital electronics, switch on 1, switch off 0, bulb on 1, bulb off 0. Means high values represented with 1, low values represented with 0. Okay, right? Now in such a case, input it's coming like this. If suppose this is just acting like a short circuit, it is acting like a short circuit. Understand? Based on the short circuit behavior, the bulb will glow. What is meant by short circuit? This is a one complete circle, one complete circuit. In this complete circuit, in this computer circuit, this is the cell, this is the cell. Here there will be a bulb. To glow this bulb, the circuit should go like this. The electrons should carry like this. Again, the electrons will go like this, like this, like this. It is complete circuit in this way. If you keep one wire here, if you keep a wire here, then what happen, you know? The bulb will not glow. Why the bulb will not glow? Why? Because now the electrons are going like this. It will take bypass. This is circuit. Now this circuit is what? Short circuit. This is very important basic idea in current electricity. Instead of flowing through this bulb, now electrons are flowing like this. Why? Electrons always preferring low resistance path. Electrons always preferring low resistance path. So like this it will go. So why? Because bulb is very high resistance. Bulb contains a very high resistance. So that it will select that path. Okay. Now see that. Now these two are in half. Means these two switches are in off, directly the bulb will glow. Understand? If these two are in on, what will happen? Instead of coming like this, the electrons will go like this, like this, like this, like this. Means in this block, no current, no electrons flow. There is no flow of electrons. So the bulb will not glow. Hope you understand. Okay, from here it is started. Yes. First, for example, if I give, it is 1, it is 0. 1, 0. 1, 0. 1 means what, ma? On. 0 means what? Half. Okay, fine. It is 1. Okay, electrons are moving like this, like this, like this. But here what happened? Half. So this circuit is not complete. No short circuit. So that like this only electrons will flow. So the bulb will glow. When A is 1, B is 0, what is output? On. LED on. On means 1 only, na? Yes. Why? Because the circuit is not complete. Yes. Second, 0, 1. Now it is 0. Now it is 1. Means what? It is half. Here only it stopped. So no short circuit. So again the electrons will flow like this only. So what is output? 1. Then it is what? On. LED on. Again, yes, again I am changing. Yes, what changing? 1, 1. Yes, it is 1, it is 1. Means it is also on, it is also on. Yes, now the electrons will carry like this, like this, like this, like this, like this. So this is blocked. No electron will come through that. Why? Because it is very less resistance area. It is very less resistance area. So now bulb will glow? No. So that it is what? 0. Bulb? No. Off. Bulb is now off. Last one, 0, 0. Both also in open. 0, 0. Both also open means no problem. Again the bulb will on. So it is what? 1. The bulb will on. So these are the outputs of LED. So what are the outputs? 1, 1, 0, 1. On, on, off, on. So 1, 0, 1. 0, 1, 1. 1, 1, 0. 0, 0, 1. So you know all truth tables of basic gates. This is related to which gate? NAND gate. Which is related to NAND gate. Not plus end. Not plus end. NAND gate 1, 0. AND gate is what? 0. 0 bar 1. 1, 0 into 1. 0 into 1. 0. 0 bar 1. 1 into 1. 1. 1 bar 0. 0, 0, 0. 0 bar 1. So what is your answer? NAND gate. What is Boolean operation is? NAND gate. Okay. So it's very important models. So important, as I said, guarantee model for all competitive exams. Okay, in a different situations I have taken different models. Just for reference you can take a screenshot better. Yes, later once again you can revise the things easily. So next, if you see in semiconductor electronics, the basic model about forward bias and reverse bias. So what is forward bias and reverse bias? When the circuit contains, when the diode, the positive terminal of the diode connected to positive terminal of the cell, the negative terminal of a diode connected to negative terminal of a cell, then the biasing said to be forward bias. What is bias? The adding of potential difference to the diode. The diode kept between potential difference. It is biasing. Forward bias and reverse bias. About this, what is forward bias idea? High potential to low potential. Positive to negative. What is reverse bias? Low potential to high potential. In forward bias what happen? Current maximum. Resistance minimum approximately 0. Reverse bias, current through diode minimum. Resistance offered by the diode is maximum. Okay, yes, we will see one model question about these diodes. Yes, it is also very important model. Which one of the following represents forward bias? Some options given. What is the question? Which one of the following represents forward bias? Forward bias. What are the options given? The first all are same. Later I will write. So one diode and one resistance. Some values they have given, so that as you have an idea to simplify this type of questions, what the idea is, what is high potential and what is low potential, and P terminal connected where and N terminal connected where we have to see, then automatically you can get a correct option. Okay, you can see now this is minus 4 volts, it is minus 2 volts, this is 3 volts, it is 0 volts. This is minus 3 volts, it is plus 2 volts, this is 5 volts, this is minus 2 volts. Okay, right. What the question they asked? Forward bias. Forward bias. Okay, we can see. Minus 4, this terminal is given minus 4, this is minus 3. Minus 4 minus 3 means low potential to high potential. Why? Because it is a higher value. So it is connected from low to high. Minus 2 plus 2, it is also low to high. Lower potential to higher potential. This is 3 to 5. This is also lower potential to higher potential. This is 0. This is minus 2. 0 is high, minus 2 is low. High to low. So what is your answer? Is option 4. Because higher potential to lower potential. This is what? Biasing. So which of the following is forward bias? Is option 4th option is forward bias. This is also one of the important model. Okay, right. Circuit related, I will give one more question, then easily you can understand. Yes. Potential in each diode is 0.7 volts. Potential in each diode is 0.7 volts. Two diodes are there. It is a junction, and another diode is given which is in reverse bias. Yes, here there will be a resistor which is connected between two terminals. This is B, this is D, which is connected to earth. Okay, this is A, this is B, this is E. Okay, see that question is what given? What the question is given? See that both the diodes used in the circuit shown assumed to be ideal and have negligible resistance. When these are forward biased, built-in potential in each diode is 0.7. For the input voltage shown in the figure, the voltage at E is V input is given 12.7 volts. 12.7 volts input is given. Okay, you can observe the circuit at A and B input is 12.7. Then what happened? Potential in each diode is 0.7 for the input. Then what is the potential voltage at point E? Okay, so two diodes are there now, left diode and right diode. You can see left diode, this is high potential to positive terminal given high potential, this is low, so this is negative. So it is what? Forward bias. It is what? Reverse bias. Forward bias, reverse bias. So ideal diode means what, ma? Ideal diode means resistance is negligible, which is ideal. So what is it is given that 12.7 volts. 12.7 volts is given. It is forward, no problem, but it is reverse. So here what is the net potential means? It is just like it is E1, it is what? E2, but it is what? Reversed. Second one is reverse bias. So what is the second one value? In each value is 0.7. So in each one is 0.7. So it is 0.7 volts. So what is your answer is 12 volts. Why? Because input has given 12.7. So second one is reverse bias 0.7 volts. So that what is your answer is? Your answer is 12 volts. Similar one question I will give you. Try to solve. Which was very important. Circuit related we are solving. It is 200. This is also 200. Here we have two diodes. Here we have two diodes which is connected ground. What the values given? See, this is 200 ohms. This is 200 ohms. V in is equals to 12 volts. Here there will be a out. This out is equals to 8 volts. Okay? Yes. Now the question I will read. The circuit shown below is working as 8 volts DC regulated voltage source. When 12 volts is used as an input, the power dissipated in each diode is. Power dissipation we have to find out. See, the total concepts related to current electricity only, but just the diodes only we are adding. Just diodes only we are adding. The diodes, general diodes which is given. Just diodes only we are adding. But you can see it is input, here it is output. So there is no effect of this. Just to make us confuse only the diodes which is given like that. It's not a matter. Now what we have to find out? Power. Power P is equals to V into I. This is the standard formula we know. Power P is equals to V into I, or from that P is equals to I square R or V square by R. Any one of the formula you can use. So yes, then first of all what we have to find out is power dissipated in each diode. Yes, power means V into I, means I we have to find out. How to find out I? So I is equals to V by R. What is V? V input is equals to 12 volts. This is 8 volts. So 12 minus 8. 12 minus 8 by this is 200 plus 200. 200 plus 200. So that is equals to 4 by 400. So that is equals to 10 power minus 2. 10 power minus 2 amperes. 10 power minus 2 amperes. What it is? Current. So power loss in each diode is equals to V into I. So what is V there? V is equals to, as you know, 4 into I is equals to how much? 10 power minus 2. So which is the correct option is 4 into 10 power minus 2 watts. Yes. The option is given 40 milliwatts. Correct. So what I did here, see that the circuit may be little confused, but the thing is what? 2 resistors, 2 potentials. Input is 12 volts, output is 8 volts. Okay, fine? Yes. Now see that power P is equals to V into I. So what I have to find out? I value. So how can I find out I value? I is equals to V by R. Difference in potential 12 minus 8, that is equals to 4. But total resistance 200. So 2 also same in series. So that 4 by 400 10 power minus 2. Current is same. Same current is flowing through diodes. The diodes are connected in series. So 10 power minus 2 amperes. Then power P is equals to, power dissipation P is equals to V into I. So what is V? 4. 12 minus 8, 4 into 10 power minus 2. Okay. So fine. What is answer? 40 into 10 power minus 2. Okay. Right. Now I will give you one question for homework. Try to solve, which is very important model. Yes. The circuit model questions only, we have more questions, especially for JEE. NEET means generally they are asking theory questions only. NEET only they are asking theory questions, but in JEE they must ask one circuit question. Actually, this is simplification of current electricity only. Let's just a little adding of the circuit elements like diodes. This is plus 4 volts. This is minus 6 volts. It is the next question. Yes, see that. Consider the junction diode is ideal. Every time they mention that ideal. The junction diode is ideal. The value of current flowing through the AB is. The value of current flowing through AB. Value of current through, this is A, this is B. Current flowing through the AB is. Yes, what we have to find out? Same. IAB is equals to VA minus VB by R. VA minus VB by R. So the two values also given, A value, B value, so that you can substitute 4 minus half minus 6 by R value 1 kilo ohm, that is 10 power minus 3. By substituting that, you can get answer. Right. Thank you. Hope you understand. A few models we have covered today. We will continue the same topic tomorrow also. Thank you. Have a nice day.